Okay, so this is questions 5 through 8 on the pre-test for Unit 3, the second in a series of videos. Um, Number 5 had about a 70% success rate. As you look at this, uh, if you're seeing structure, then you're seeing a square root plus 1 equaling variable. So in terms of an idea, um, and working hard and working smart, you want to realize that this is probably a perfect square in here. So what values of x, at least if you're searching integers, what integer values of x would produce a perfect square if you're sort of getting familiar with the question. As a process, um, we have the radical in here, a square root. To get rid of a square root, we want a square. But before you do, and there are other ways you could approach this, but the easiest way is to isolate the square root. Get the square root alone if you can on one side of the equation or the other. And then uh, what I'll do, opposite of squaring, is square rooting and vice versa. So we'll square both sides. Didn't square all the terms, notice. I said square the sides. So obviously on the left, you get 2x plus 1. The radical's been removed. That's the point, right? On the right, it isn't simply a matter of saying x squared minus 1 or x squared plus 1. When you square that quantity, you are multiplying it times itself, right? So you're doing x minus 1 times x minus 1. And when you do that, you should get x squared minus 2x plus 1, right? First, outer, inner, last. Then from here, you recognize the quadratic nature of the problem. And so we get one side to 0. And I'm going to make the left-hand side go to 0. Use the additive inverse and get x squared minus 4x. Okay? And notice the ones uh, cancel each other out, so to speak. The plus 1 additive inverse to the other side, it's a minus 1. And so the constant term is gone. From here, the factoring becomes easy because um, it's merely x times x minus 4, right? Now, at this point, x equals 0, x minus 4 equals 0. Okay? So you say, good. I've got two answers. I've got x equals 4 and I've got x equals 0. So I go to my WebAssign answer box and no need for the variable. I put in 0, comma, 4. And it will give you the big red X. Why? Because that 0 right there, that 0 will not check. All right. And when that answer pops out at you again, let's go back and look at the structure. Think about it. You've got a square root right here that's a positive square root. There's no negative in front of this. So this is a positive number. And then you add 1. There's no way that's going to be able to be equal to 0. You have what you know right here is a positive quantity. Okay? You're adding 1. How is that going to go to a 0? That can't happen. That's about seeing structure. Yes, surely you could go in here and check 0, right? You could plug in the 0 and you could see that you get square root of 1 plus 1 equals 0, and you get 1 plus 1 equals 0, and so 2 equals 0, and you go, okay, that doesn't check. I reject that answer. But more than that, at the university level, we want you to be able to see structure. And yes, we want you careful and cautious and checking things, of course we do. But looking at that answer and now seeing the structure of the problem, it's identifiable that that's an impossible answer. right? So you want to be aware of situations like that. So the only answer to that one was 4. And so now we'll move on to number 6. Success rate dropped off a little bit more here. I think it was something in the neighborhood of 65%. Um, if factoring the quadratic, factoring second degree polynomials is the stuff of the high school realm, this one is equally as easy. It's going to be an x squared and an x squared if it factors, right? You can use all the same AC technique that we talked about with uh, factoring ax squared plus bx plus c. You could actually employ that here, rewrite the middle term, and then use the factoring by grouping technique. Sign language still works. These are both negatives. Got to be two negatives, right? Sign language are telling. Same as the neighbor, right? Two negatives, all right? And to get 40 as a product, you're going to use 8 and 5, okay? Then we set our factors equal to 0 here. And so x squared equals 5. And so x, right, do the square root. And remember, when you do a square root, you must consider plus and minus values. So there's two answers right there. There's negative square root of 5 and there's square root of 5. Okay? Now, on the left-hand side here, we get x squared equals 8. We get square root, and so x is plus or minus square root of 8. And I believe that answer would have been acceptable, obviously put into the answer sheet with into the answer space with commas between them. It does turn out that this one actually factors out a perfect square, and so we got plus or minus rad 2, 2 rad 2. And so in our answer space on WebAssign, we want negative 2 square root of 2, comma 2 square root of 2, comma negative rad 5, comma rad 5. And that would have gotten you the full credit. Okay. To leave out the negatives, you wouldn't get full credit, right? Put them in any order you like, separate them by commas, it'll be good. All right. Now, on number 6, the success rate really dropped off. Only about 35% of students were successful with this question number 7. Um, Fractional exponents, right? Well, the structure is the same as you see in the high school realm. Okay? That's a 4/3 power. It's the same in a lot of ways as the problem we just saw. Well, how can I load up? Well, first of all, what about the signs? If it factors, it's going to factor into two minus signs, right? Read your sign language. Now, to get x to the 4/3, I'm going to try x to the 2/3 and x to the 2/3, right? When you multiply x to the 2/3 times x to the 2/3, what do you do when you multiply numbers with the same base? You add the exponents, right? So that's going to give you x to the 4/3. Now, how are you going to make 6? Going to use a 2 and a 3. All right? And so there you go. Set your two factors equal to 0. X to the 2/3 minus 2 equals 0. X to the 2/3 minus 3 equals 0. Now, a little bit of a lesson, and maybe people got this factored. Maybe this wasn't where the breakdown occurred. Maybe it was at this point that the breakdown occurs. What does x to the 2/3 equals 2? What does that mean? What does that fractional exponent mean? When you have an x to the a over b, what do each of those pieces mean? Well, the b is the root, and the a is the power. So when you have a fractional exponent, right, that's old school notation for this. It's the b root of x. It's the root of x to the a power. or if you prefer, it's the b root of x to the a power. They're at the same level of order of operation, so you can write it either way. All right? So think about it. If the cube root of x squared is 2, how do I solve that for x? Well, what's the opposite of cube rooting? The opposite of cube rooting would be to cube, wouldn't it? Cubing and cube rooting would undo each other, so to speak. And so we get x squared equals 8. 2 times 2 times 2. And now, how do we solve for x at this point? What's the opposite of squaring? We do square root, right? And so that gives us x equals plus or minus square root of 8. All right? Which simplifies to 2 square root of 2. Now, in a similar fashion over here, x to the 2/3 equals 3. And again, I'll note for you, this means cube root of x squared equals 3. All right? So I cube both sides. I cube both sides. Cubing both sides, the cube gets rid of the cube root. We get x squared equals 27. Do a square root, and x is plus or minus square root 27, which gives us two answers. Gives us plus or minus 3 square root of 3. All right. So 4 answers for the question that would go into my WebAssign answer box. -2 rad 2, 2 rad 2, -3 rad 3, and 3 rad 3, separated by commas. I believe it also, I can't swear to it, I'd have to look at the code. I think it also would have taken the plus and minus rad 8 and plus and minus rad 27. I don't think you have to simplify them, but I need to check the grading code to make sure. Um, it's a better practice to simplify them. So that was a difficult exercise. Only about 35% uh, of participants had that solution. So, right, fractional exponent. Understand what it means. The bottom number's the root. You raise it to that power to get rid of it. The top number is the power. You do that root to get rid of that. In short, if you have x to the 2/3 power, right, equals 2, you can raise this to the 3/2 power. What do you do when you multiply the exponents? What do you do when you raise power to a power? You multiply the exponents. So that gives me x to the 6/6 or x to the first. All right. Now, you do have to be very careful that you don't lose the signs. You got to be careful you don't lose the signs on that. All right. So that's about the only pitfall of doing it that way. One more, question number 8 had an equally poor standing, had about 35% get it right. That's fine. We're not worried about people missing questions this time of year. It's about the practice. It's about being ready for the fall. And so we got x, that's a 1/2, minus 3x to the 1/3 equals 3x to the 1/6 minus 9. Okay? So the first thing I'm going to do is get exponents that are the same. So I got x to the 3/6 minus 3x to the 2/6 equals 3x to the 1/6 minus 9. as you do with powered equations so often, I'm going to get one side to 0. This certainly isn't the only way to do this question. I just think it makes it a little more clear what's happening. Um, and now with 4 terms, what comes to mind when you have 4 terms? Right? Got one side equal to 0 now. You have 4 terms, we're going to employ pairwise factoring. Going to employ factoring by grouping. So look at the first pair. They certainly share an x. And what's the rule on factoring out a term? You factor it out to the lower power, right? We see 3 6, we see 2 6. We're going to factor it out to the 2 6 power. Now, if you divide out 2 6, what's going to become of that x to the 3 6? What's that going to go to? I hope you see it's going to go to the 1 6 power. When you divide, which is what you're doing when you're factoring, you subtract the exponents, right? X to the A divided by X to the B, about elementary algebra, X to the A minus B, right? That's all I'm doing right there. See the structure. Minus 3. Second pair, I see a negative here. I'm going to factor out the negative, and they both share a multiple of 3. And when you factor out that 3, coincidentally, you get x to the 1 6 minus 3. Now again, as we've done these 3 weeks, see the structure. See the common element. X to the 1 6 minus 3 is common to both of them. All right? So we're going to factor that thing out. That's getting factored out of each of these terms. And so we got x to the 1 6 minus 3. And what's going to be left? First term is going to be x to the 2 6 minus 3 equals 0. All right? So get to review, get one side to 0, right? Get a common exponents there, common base on the exponents. Get one side to 0. Pairwise factoring. All right? And now you've got a product that equals 0. Now, working with this x to the 2 6 minus 3, I hope you see that's x to the 1 third minus 3. And so x to the 1 third equals 3, right? When you bring this over to the other side. And now what does that x to the 1 third mean? What's the meaning of that 1 third fractional exponent right there? That means cube root of x. So if the cube root of x is 3, how do you figure out what x is? How do you get rid of a cube root? Well, you raise it to the 3rd power. Just like squaring gets rid of square roots, same idea. So there's one root of 27, okay? And then the other side, 1 6 minus 3 equals 0, gives me x to the 1 6 power equals 3. So what am I going to do? That's the 6th root of x. That's what that denotes. And so to get rid of a 6th root, you raise it to the 6th power, which means 6 3's multiplied together, or 1, 2, 3 9's multiplied together. Well, 9 times 9 is 81, times another 9, right? So our other answer, 729. Put them in the answer box, separate them by a comma, and that one's done. If there's more questions about these or these fractional exponents or how to solve those situations, just drop us an email. Send us a note through the WebAssign portal, or send an email to CU Math, and we'll build some more for you. Okay. Back in just a few with the solutions to the other 2 questions.